Assalamu alaikum. Today we'll start electrical circuit 2 course. In electrical circuit 2 course we have many topics related to AC circuit. We can show here course semester plan for this course and show what is the book we will use, which is introductory circuits analysis, same book which we used in circuit 1 13 edition. Okay, and for course description, this is an intermediate level model that extends the subject matter of circuit 1. It concentrates on AC analysis of resistive, inductive and capacitive circuits. Not like circuit 1. Circuit 1 we concentrate about only resistive elements. Circuit using various methods of and theorems. It looks at polyphase system. Polyphase system means we'll concentrate about three-phase system. Okay, and power calculation for single phase and three-phase delta Y connection. Delta Y, when we are dealing with three-phase system later, end of this course, we have two types of connection, one called delta connection, one called Y connection. It also covers RLC resonant circuits and associated effects. You can see here the subject divided through the weeks. Okay, first two chapters concentrate about math and physics, especially in math, because when we are dealing with the AC, we need to know about different form of polar form, rectangular form, how to convert from this form to this form, because in circuit 1 we were dealing with the fixed number. We can say current 2 ampere, voltage 100 ampere, and we can do other calculation. But here we cannot say this. It has sinusoidal waveform, and we have variable, and we need to deal with the angle. All these we need to deal with the vectors. All these we studied in math, and we studied some concept in physics, and we will have a small review in chapter 13 and 14. Some topics in chapter 14 start talking about electrical, which is the basic element of and phasors, the response of basic R, L and C elements to a sinusoidal voltage and current. We will see what's the relation between the voltage and current when we apply the voltage through resistor or inductor or capacitor. Okay. After that we have two chapters about circuit series and or three chapters, chapter 15, chapter 16, chapter 17. All these chapters talking about electrical circuit, series, parallel, and some examples in chapter 17. All the rules applied in circuit 1 we will apply it in circuit 2. For example, voltage divider rule, current divider rule. Okay. After that we will see some methods of analysis and selected topics. If you remember, in circuit 1 we studied source conversion. In chapter 20 we will start talking about power for AC. Everything about the power in the AC we'll start talking about in chapter 20. There is two chapters, chapter 21, chapter 22, about something called resonance. We will have the details inshallah later, and filters. End of this semester, 3 weeks or 4 weeks, we'll talk about a three-phase system. All type of connection, how to calculate the source side or load side. We will concentrate about a three-phase system end of this semester. Okay, now we'll start chapter 13, which is about sinusoidal alternating wave form. In this chapter, we'll study 5 sections: 13.4 sinusoidal waveform, 13.5 general format of sinusoidal voltage and or current, 13.6 phase relations, 13.7 average value, and we will conclude this chapter by effective RMS value. Okay, we will concentrate about the book, and you can open your book and follow what we are talking from section 13.1 until 13.4, not with us, but it's a very basic information about electrical, and you studied in circuit 1, but we will go to section 13.4. Since we said AC circuit, AC circuit means the voltage or the current, the wave for the voltage or the current, it is not fixed like circuit 1. We are dealing with fixed value. Okay, now we will talking about any waveform which is changing its value every second or any time, and it has two polarity, positive and negative. Okay, if we have the any waveform, not important to be sinusoidal waveform like this. Okay, it can be square waveform, sawtooth, or anything. Okay, if it has positive and negative and changing its value during the waveform, this means AC waveform. Okay, but for electrical, since we generate when we generate electricity, we generate sinusoidal waveform. Okay, the sinusoidal waveform is the only alternating waveform whose shape is unaffected by the response characteristics of R, L, and C elements. This waveform has some information we need to know about it before we start dealing about this waveform. For example, when we say talking about degree or radian, okay, 1 radian equal 57.296 degree, like this. This is the circle. If we say 1 radian, it is 1 radian. If we say pi, we know pi, it is in degree 180 degree. But equal what pi in radian? Equal 3 radian. This is first radian, and the second radian, and the third radian, and 0.14 radian. If we say if we say pi 3.14 and multiply by 2, it will be 6.228. If we say 2 pi, this means 2 pi 360 degree, which is 6.28 radian. When you are dealing with your calculator, be sure you put a degree or radian, depend on your question. Okay, don't forget. The quantity pi is the ratio of the circumference of a circle to its diameter. Okay, if we have radian and we need to convert it to degree, or the opposite, if we have degree and we need to convert it to radian, what is the formula we need to use? You can use this formula, which is in 13.6 and 13.7, degree multiplied by over 100, you will get radian. If you have radian and you multiply by 180 divide by, you will get degree. Let us see some example here. For example, we have 90 degree and we need to convert it to degree, to radian. 90 degree multiply by divide by 180, you will get pi over 2 radian, and similar for 30. Now what about the opposite? If we have pi over 3 radian, okay, pi over 3 radian, and we need to convert it to degree, you will multiply 180 by pi with pi cancel, 180 divided by 3, you will get 60 degree, and similar to 3 pi over 2, you will get 270. We have another terminology which is called angular velocity, or before angular velocity. You can see here this sinusoidal waveform, okay, one in degree, one in radian. If we say degree, it will be 0, 10, 20, 45, 90, okay, until we reach 360. And if we say it by radian, it is 0, 45 equal pi over 4, 90 equal pi over 2, 135 will be 3 over 4 pi. All these we studied in math, but here only for review, because we need this during this course. Angular velocity, since we will deal with something rotating with circle, okay, we need angular velocity. What's the formula for angular velocity? Which is the distance over the time, okay? Like if you say the speed, what's the formula for the speed? You will say the distance over the time. Here the distance, what is the distance? It is degree or radian, angle, okay? And the time will be the second. If we need to write it by formula, omega equal alpha over t. What about if we need to know alpha? Alpha equal t multiplied by omega, okay? This is general format, this is general formula, okay? What about if we know that the period? If you know something called period, what is the period? The period, the time the waveform start repeat itself, okay? For example, assume this 2 seconds from here to here, and then after 2 seconds it will repeat itself another time, 4 seconds, and then will repeat itself another time, okay? Once the waveform repeats itself, okay, this is end of the period from here to here, okay, for this waveform. Okay. What does mean from 0 to this point in sinusoidal waveform? This means the angle here in this point equal what? Equal 360, or by radian 2 pi. This means we can say omega is equal alpha over t small, or we can say alpha omega equal 2 pi. This means all the waveform divided by the period, full period, okay? This is a special case when we talk about this formula, okay? طيب, we know before in physics that, let us write here something, period equal what? By frequency. It's equal 1 over if you remember. Frequency, which is hertz, cycle per second. Okay? طيب. Go to the back to the book. we say the opposite of 1 over t equal f, this means we can write the formula omega equal 2 by f, either 2 pi over t or 2 pi f. It's very important formula, 2 pi f, omega equal 2 pi f. Okay. Let us go through some examples, direct examples. Determine the angular velocity of a sine waveform having a frequency of 60 Hz. Direct. We need angular velocity and we have the frequency. Multiply 60 by 2 pi, you will get 377. Please pi here by radian. This means 3.14 when you use your calculator. 2 multiply 3.14 multiply by 60, you will get 377 radian per second. Another example, determine the frequency and the period of sine waveform in figure 13.7. This is figure 13.7 B. The information given here, omega equal 500 radian per second. Then it's required to find the frequency or period. We know we can start by this formula or this. If you find the frequency, you will find the period. If you find the period, okay, if you find the period, you will find the frequency. Anyone you need to start. Let us see the book start by what? Start by omega 2 pi over t. This means t equal 2 pi over omega, 2 pi over 500, which is in the book, in the question. Okay, 2 pi, we will write it here by also not 180, it is 3.14. 2 multiplied by 3.14 divided by 500, you will get 12.57 millisecond. Frequency, it is the opposite of the period, 1 over this answer. Okay, you will get the frequency 79.58 Hertz. Here another example, third example. Given omega 200 radian per second, determine how long it will take. What does mean? He is asking about what? The time. Okay, sinusoidal waveform to pass through an angle of 90 degree. We know that alpha equal omega t. But what about if we need to find t? This means alpha over omega. We have omega now, and we have degree. You can convert degree to radian. 90 equal pi over 2. Pi over 2 over 200, you will get pi over 400 equal 7.85 milliseconds. And so on. You can go about the other example. Now we'll talk about general format for sinusoidal voltage or current. Since we said the current, our current AC and voltage in this course, we will concentrate about sinusoidal waveform. Let us talk about the format, general format about any sinusoidal waveform. If you need to express the sinusoidal, you will say AM sine alpha. It is similar to math, like we studied in the math. AM, what is AM? It is the peak value. It is the amplitude. See here, the peak value AM multiplied by sine alpha. For example, you need to find the value in this point. Okay, what you will do? You need to find the value in this point. You will find the alpha here, the angle here, for example 45. You will substitute sine 45, you will get some value and multiply by the peak. Assume the peak here 10 volt or 100 volt or 20 ampere. Okay, depend on what we have, current or voltage. AM sine alpha, and we know alpha equal what? Alpha equal omega t. Then we can write another format, AM equal sine omega t. Similar, depend on your question. What about the voltage and current? If we need to convert math to electrical, let us say I or E. E, some books say E, some books say V about the voltage. When you need to express the sinusoidal, concentrate here. The I letter written by small and E written by small. Okay? When you start by small, this means you will write sinusoidal expression. Because later we will write I in capital. I small equal Im, which is similar to Am, and this is the peak for the current, sine omega t, or Im sine alpha, similar to voltage. Em sine omega t equal Em sine alpha. Let us see some example, substituting. 13.8, given E equal 5 sine alpha, determine E at alpha equal 40 degree and alpha equal 0.8 by. This is by degree, this is by radian. You need to convert the radian to degree and then find the answer. 40 degrees is substitute direct. 40 sine 40, you will get sine 40.64 by calculator. Multiply by 5, you will get 3.21 volt. For the second part, 0.8 by, you need to convert this to degree, like here, from radian, multiply by 180, divide by pi, you will get 44 degree, and substitute sine 144, multiply by 5, you will get 2.94. See, when we change the value of the angle, the value of the voltage change. It was 3.21 and 2.94. And concentrate. If your answer, final answer, come more than the peak, your answer is wrong. Our peak here 5. We cannot exceed this number. Maximum 5. When we put sine 90, 1. Okay? 1 multiplied by 5, 5. More than this, you cannot find. Please. Some students use a calculator. By mistake, the answer come any number. He make any mistake. And the answer, for example, come 9 point something, 8 point something. And he will write the answer and leave. This is wrong. You need to think before put your answer. 5 is the peak, or for example the peak was 100, you cannot find answer more than 100. Okay? Right. What about the opposite? We have this formula and we have the final answer, we have the peak. The question asks about the angle. You need to find what? You need to find inverse. You will take the inverse. You will divide by Em. This cancel in this part. E over Em equals sine alpha. Right. What about alpha? If you need alpha, only alpha, we will take the sine inverse E over M. You will get the alpha. Okay. Or if we have the current, it's similar. And this one example, go through it. It's easy, direct, substituting only. But we need to concentrate about. If he asks you about the angle, sometimes we have two options. For example, here 10 sine 377t, the voltage was 4. He's asking what was the alpha. Okay, if we say the inverse sine E over Em, E, the final answer 4, Em 10, sine inverse 4 over 10 equal 23. Okay, 23 in this side, if you see the sign like this, okay. The value for intersection come here and here. Okay, 2 times. This means this 23.58, and we can say 180 minus 23.58. You will get another value of answer. Alpha 2 equal 156. Okay, if you need to convert it by part B determine the time at which the magnitude is attained. This means you need the time. Convert it to radian. 23 pi over 108. It will come 0.412. And then apply the formula, which is T equal alpha over omega. Alpha by radian, omega 377 radian per second. From where we get to 377? From the question. Okay. The answer will be 1.09 millisecond. And for the other value of angle, you will get another time. The time here was 1.09 millisecond, and here was 7.24 millisecond. Some example you can go through it. Try to solve examples as much as you can. Let us start about section 13.6, which is phase relations. Also this is math, but we need, and not all the section, but some information we need. AM sine omega t, this is what we before we wrote. But what about if the waveform not started from 0, start from minus or positive, minus 10, minus 20, minus 40, or plus 5, plus 20, plus 60, any value. Okay, you need to put plus or minus theta, plus or minus theta. You can say here, we'll write something. The general format is AM sine omega t minus theta is the formula, is the general format. Okay, theta itself, it can be positive or negative. If it is negative, it will be minus, it will become positive. Okay, for example, we say plus 40. In this case, theta equal what? Theta equal minus 40. Because if it is substitute here, minus 40 minus multiplied by minus, which is in the formula itself, it will become plus 40. Okay, and here if we say theta it is in minus side. Okay, because this formula they write it by plus theta, because it is minus theta. Here if theta start from here positive, this means say minus theta positive. Okay, at the end shifted by pi, 2 pi plus theta, everything shifted by theta. The start from theta, 180 shifted by theta, 360 shifted by theta. Okay, we know that we have sine here, and we have cosine. Cosine starts from minus 90. There is a relation. It is the same waveform, but there is a relation between them. If we say cosine equal what? Since we know the shift, it is similar to if we say sine omega t plus 90. Plus 90, this means that theta equal minus 90. Cosine start by minus 90, shifted from sine. And similar if we need to say sine. What is sine? it is cosine omega t minus 90. Minus 90, since sine, this is the sine and this is the cosine. If we say cosine shifted by 90 degree, this means start from 0, it will be equal sine. Okay. We have a very important terminology in this course called leading and lagging, as we see in the lab. Leading it's mean متقدم, lagging متأخر. Okay, leading, if we say cosine lead sine by 90 degree, يعني cosine متقدم على الساين 90 درجة. In the opposite, we can say sine lag cosine by 90 degree. How to distinguish from the figure here? See this point? Cosine start and then after positive side reach 0 before sine reaching the 0 here. This means cosine reach 0 before sine. This means cosine lead sine. Okay? For any waveform, if we need to distinguish between them, who is leading, who is lagging, okay, you need to look about who reach 0 before, who reach 0. Cosine reach the 0 here, okay, and sine reach the 0. Cosine reach in the 90, cosine reach 0 in 180. This means cosine متقدم على الساين by 90 degree. Okay, or we can say the opposite, sine lagging cosine. It is similar by different way, we say same information by different way. Leading and lagging. Leading متقدم, lagging متأخر. Okay, you can see here, I think see here, cosine curve is said to lead sine curve by 90 degree. Okay, we have some properties in math, we can use it. This cosine alpha equal sine alpha plus 90, sine alpha equal cosine alpha minus 90, as we said here. Minus sine alpha equal sine alpha plus minus 180, minus cosine alpha equal sine alpha plus 270. Okay, we have another properties here and about sine and cosine. Sine, it is odd function. This means sine minus alpha equal minus sine alpha. But cosine minus alpha, you can say it is equal cosine alpha. It will not change the value if we put minus inside cosine. This is some properties we will use it during our course, especially in the beginning. See here, if we say voltage equal minus EAM sine omega t, from this formula, any minus outside, we can write it plus or minus 180 sine alpha plus 180, or it is equal omega t minus 180. This comes from this formula. You can say the phase relationship between two waveforms indicates which one leads or lag the other by how many degrees or later. Okay, here's some example. Some it is very clear, sine with sine, assume this voltage and this current. Some also sine with sine, some cosine with sine. If it is come cosine, we need to convert it by mathematical properties to sine. and then we see the relation. The question was, what is the phase relationship between the sinusoidal waveform of each of the following sets? This means how many degrees means between voltage and current. Okay, let us draw one by one. Here the first one, voltage, the peak 10 sine omega t plus 30. Plus 30, this means the waveform for the voltage start from where? Start from minus 30. See here, started from minus 30. Okay, from minus 30 is the voltage. Okay, and what about the current? Start from, it is plus 70, this means start from minus 70. 30 plus 40, it is not start from minus 40, it is started from minus 70. 30 plus 40, it is 70. Okay, what is the shift between them, between starting of current and voltage and current? This is 40 degrees. And if we say the lead and lag, before you see the answer, here, who is leading? The other. The blue one, reached 0 before voltage. Reaching the 0. Okay, this means I lead V. I lead V by 40 degrees. Okay. Please, my student, it is all math. Still, we did not talk about electrical. They said V and I only just to start talking about voltage and current, but it is math. It is math. Until now, math. Here, let us go to C. And B, D, E, you can go by yourself. C. C, it is 2 cosine omega t plus 10 and 3 sine omega t minus 10. Can we see the shift between them 20? No. We need to convert cosine to sine and then determine. What is the properties about cosine to convert sine? See here, the cosine we can convert it to sine if we add 90 degrees. 10 plus 90, as we mentioned before, it will be 100. Now we can compare the current, this current with this voltage. Let us draw part C, the current. See here, this is the part C. This is the waveform for part C. The I by blue start from 100, minus 100, since it is plus 100, will start from minus 100. Okay, and the voltage, if you remember, the voltage was started from 10 degrees. Since it's minus 10, this means the theta 10. The theta start from 10. Now, what is the shift between them? Here 100, here 10, the total 110. The shift between them. Who is leading the other? Here the current reached the 0 and the voltage reached the 0. This means the I lead V. Let us go to the answer. I lead the V by 110 degrees. Please go through other parts to solve the question. Now we will go to another section. 13.7, average value. It's from name average. If you need to find average for anything, okay, for example, you win today 10 reals and tomorrow you win 20 reals. Okay, during 2 days you win 30 reals. What's the average for your win? It is 10 plus 20 divided by 2 days. This means 30 divided by 2 equal 15. This is your average. Similar here, we can apply similar idea about the average here. See this waveform, area 1, area 2. If you need to calculate the area for this, he said assume we went to Riyadh during 5 hours. First 2 hours we go by 60 mile per hour. Okay, 60 mile per hour, and from 2 until 2:30 we stop. But from 2:30 to 5 o'clock we go by 50 mile per hour. What's the average speed? Average speed during all the period. Okay, we need to calculate the area here and the area here and add them, divide by total period. The average speed equal area under the curve divided by the length of curve. Area 1 equals 60, the width, the height 60 and the width is 2. 60 multiplied by 2, add during this period here, half hour, it was 0, no need to write it. Okay, 0 by half hour, no need. But for the remaining 2.5 hour from which is 2.5, it was the speed 50 degrees. The answer 225 divided by the total area, total period, sorry, 5 hour, not 4.5. Don't assume this because it's 0 we need to make it 0. No, the total period from 0 to 5, 5 hour. Okay, the answer 45. This means the average value was 45. Okay, general formula, we can average value said algebraic sum of areas, any type of waveform, we can apply this formula, algebraic sum of areas divided by the length of curve. We need the average value on sine wave. Since we are dealing with the sine wave, we will apply this algebraic sum of area. Okay, this is some example you can apply similar to the speed of the car. Example 13.4, go through it. 13.5 also. But when we are talking about waveform similar to sine, how we can calculate the area under the curve of sine wave? If you remember in the math, if we need to calculate the integration of the sine waveform, the integration mean the area. Okay, this means if we am sine alpha integrated am sine alpha, you will get the area. Okay, if you apply this, go through the integration steps, you will get by end of area equal to am. Any sine wave, you can calculate the first half of sine from 0 to pi by 2 am. Any area similar to this area, similar to sine, you can multiply the peak by 2. This equal area. Okay, but what about if we have sine wave, full sine wave positive, sine wave negative? Here am, here am by minus. This means the area here 2 am and the area here 2 am. But this in positive, this in negative. If we apply the formula here, algebraic sum of areas, the first area 2 am, the second area minus 2 am. Sorry, yes, here 2 am minus 2 am divided by 2 pi, the total period. But the numerator is 0, this means the area is 0, since the normal waveform of sinusoidal waveform, it is 0. But if the waveform shifted up or down by any value, we will have a value either plus or minus depending on the shift up or down. Okay, this is the example 13.7. And example 13.8, it is similar to sine from 0 to pi and 0 until 2 pi. This means the total period 2 pi. The area here 2 am plus 0, no area here. From pi to 2 pi, no area. 2 multiply the peak 10, 20. 20 divided by 2 pi, you will get 3.18. This is the idea we need about average value. Last section, we will talk about effective RMS value. RMS value, which is root mean square value. This is very important terminology in electrical. We will use RMS everywhere, all the courses. Even when you measure the value in your lab or your home and find the voltage, for example 110, this means RMS value, not peak value. Okay, it will help us determine the amplitude of a sinusoidal AC current required to deliver the same power as a particular DC current. Okay, this is the meaning of RMS value. This is an explanation how to find the final answer for relation between the DC and peak value. Okay, the relation between the peak value and DC, it is 0.707. If you multiply any peak value by 0.707, you will get I DC, which or I RMS. The equivalent DC value of a sinusoidal current or voltage is 1 over root 2 or 0.7. 1 over root 2 equal 0.707 of its peak value. The equivalent DC value is called RMS or effective value of sinusoidal quantity. From its name, RMS, root mean square. We have root, we have mean divided by t, mean and average, and we have s square. We need to square the waveform, any waveform. Now we can conclude here. If you have peak and you find the RMS, this is the relation. The value of peak divided by root 2 or multiply 0.707 by the peak, you will get RMS. And similar to voltage. If you have the opposite, you have the RMS and you need to find the peak, it will be multiplied by root 2 or 1.414. Okay, let us see example. Find RMS values of a sinusoidal waveform in each part. We have part A, B, C. You don't need to look anything about the period, about how long the waveform. Only you need to look about the peak value. The peak value here 12. This means if you divide 12 peak divided by root 2, you will get the answer. And here similar, since it is 12, it's different waveform, this part A different than part B, but the peak same. This means the RMS the same. RMS value 12 divided by root 2, but here 169.7 divided by root 2, you will get 120. And for A and B 8.48 milliampere. Okay. Here example 13.21, 120 volt DC source, figure 13.61a, delivers 3.6 watt to the load. Determine the peak value of the applied voltage EM and the current if the source here is to deliver the same power to the load. Okay, now we have the voltage, we have the power, we can find the current. So, then any value given like this in the question, it is RMS. It is RMS. Please concentrate. If it is not mentioned number with sign, if it is fixed number, and he said this fixed number it is AC, this means RMS value in AC system. Okay, or he said this this circuit related to this. Okay, and we need to find the voltage and current here. Now divide by 3.6 divided by 120, you will get 30 milliampere. But if we have now RMS value for the current, if you multiply by root 2, you will get the peak, and 120 if you multiply by root 2, you will get the peak value for current and voltage. This example, but not sine wave, but we can go through it quickly. Find RMS value of waveform. How to find the RMS value for square or something like this? We said RMS. R mean root, M mean square. The waveform we must square it. Right. If it is this is 3, if we square it, it will become 9. See, 9. And this is 1 minus 1. If we square minus 1, it will become 1. Okay, and then calculate the area under the curve here. 9 by 4 plus 1 by 4. This is 4 period and this 4 second, I mean. And you need to divide by the total period from 0 to 8. Okay, after that you make root 40 over 80, it will be 5, root 5, 2.24. Okay, and there's another example similar. You can go through it. Please try to solve examples. I did not solve all the examples. Go through the examples as much as you can. Okay. By this we will conclude 13.8 and concluding the this chapter. I mean the sections which we needed. Next lecture we'll talk about chapter 14 inshallah.